3D printing. Personally, it's one of my favorite machines after CNC roundering. But one of the flaws with it is that you probably shouldn't use it for anything meant to be strong. But what if you were able to use it for other purposes, such as rocket parts? And that brings us to this rocket that I call Bullet V3. In this video, I'll be talking about how I designed it and flew it, because it went through several iterations to get to what flew. Howdy you guys, I'm the Young Rocket Man, and this is how to 3D print a rocket. This all started several months ago, when one of my friends at school told me that he and some of his friends were 3D printing rockets of their own to fly and see who could make a better rocket. Since he was having a hard time deciding on his design, he decided to ask me if I could simulate his rocket in my software OpenRocket to verify it worked, and I also helped redesign it from there. In the process of helping him, I noticed several things about the way that he and his friends were making their rockets, and I thought, what if I tried with my own design? Well, over a year prior, I had gotten a student subscription to Onshape and had made a design for a simple 3D printed rocket, but at the time it kept not working and I couldn't figure it out, so I had shelved the project for until I could figure something out to make it better. And seeing these kids make rockets made me realize the flaws in my design. When I had originally designed my rocket, I had used fins in the shape of a parallelogram, with part of them sweeping downward past the engine. I realized that because the printer was printing such a small surface at the beginning, it was not adhering to the bed and would lift up quickly. So during the time that I had a craze in ridiculous rockets, I'm looking at you, Duct Tape Rocket, I redesigned the 3D printed rocket to be better. Version 2 of the 3D printed rocket was completed in mid-July, and the design was quite simple. The four fins were shaped as trapezoids and would not go past the bottom of the engine mount. Apart from this big change, I also redid the hole on top. When I had first designed the rocket, I didn't know about the hole tool in Onshape, so this time I came back and made a legit hole for the shock cord to go through. Other than that, everything would remain the same. The engine retainer in the middle had a chamfer on top of it for extra stability, and I made some minor changes to the shape of the cutout in the shoulder of the nose cone. Once these changes were done, I went ahead and printed it on my Elegoo Neptune 4 Pro. The print went perfectly, and the rocket was set to fly apart from getting a parachute and shock cord. But something kept nagging at me about the design. I had wanted to 3D print as much of this design as I could, but one thing that I didn't 3D print was an aft engine retainer due to the complexity of the part. But about a week before launch, I decided I wanted to try to make a reusable plastic engine retainer on my 3D printer. So after a few days and multiple different design iterations, this is the design I came up with. There's a small cutout in the bottom of the fins that the retainer is supposed to fit through in order to have it flush with the fins, and there's a chamfer on top of the retainer to make sure it wouldn't increase drag too much towards the bottom of the rocket. The hardest part was the threads. I had created custom threads before in Onshape for personal projects, but this was entirely different. I went with bigger threads than I had before for strength, but it also meant that I had to increase the outer diameter of the airframe to accommodate these bigger threads, so V3 does have thicker walls. It's not a big difference, maybe a few hundredths at most. Besides the aft retainer, I also pushed the forward retainer further up the rocket so that the aft retainer would be almost flush with the bottom of the fins once the motor was inserted. Once this was done, I went ahead and printed it. 2 3D printed rockets, with no idea how they would do. Fortunately, you don't need to see to wait how they did. You can see right now.
Yay. Next up we got Doug. He's on A. What's on A2? You have a card for one on A2? You have a card for A2 at all?
The flight went well, and apart from breaking the shock cord, everything went well. V3 was undamaged. The two things, though, that kind of sucked with V3 were the fact that it used a terrible shock cord and how far up the engine sits in the rocket. I'll start with the former. The shock cord is made of 3 fishing lines, each rated to 12 pounds of force. The lesson here is simple. Use a stronger shock cord, such as Kevlar or something much stretchier like an Estes shock cord. The other issue, though, was the engine mount. I knew about this issue before launch, but because the motor sits so low in the mount, maybe a tenth of an inch sticks out, and because it is snug in the rocket, I need a vise to pull it out, and my only vise is at home. Fixing this should be relatively easy though. I just need to widen the tube a little bit so the motor is a little more loose and slides easily. Aside from these few issues though, everything worked well. And in fact, despite coming down without a parachute, the whole main body of the rocket came out perfectly intact. So I think this means it wants to fly again. And if you want to see Bullet V4, drop a comment saying so. And while you're at it, like this video and subscribe so you don't miss any more videos. If you made it to the end of this video, congratulations, and I hope you enjoyed it. See you next time.